Myself, Dr. Ashwini Kumar Gupta. Today, I'll be going through this our IUPAC nomenclature series, in which I'll be taking lecture 5. Today, we will start with the nomenclature of alkenes and alkynes. Alkenes and alkynes. Yeah. So, today we will do with first rule 1. In rule 1, we have to select the longest carbon chain containing maximum number of multiple bonds as parent carbon chain or PCC, IPC, as we have seen in the previous lecture. So the longest carbon chain which is considered as a parent carbon chain, only that which has maximum number of multiple bonds. That means a chain which has maximum number of multiple bonds is considered as the parent carbon chain. Take for example, and if we take, see, it is here, if normally if we see 1, 2, 3, 4, 5, as we have seen in the previous lectures, this will be 5 carbon straight chain. This will be the longest parent carbon chain, but as per rule, it should contain the maximum number of multiple bonds. If I see the maximum number of multiple bonds, then happens to be 1, 2, 3 and then 4, because here it contains two multiple bonds. So I will say this becomes the parent carbon chain. Irrespective, there is 4 carbon here and here it happens to be 5 carbon, but still, since it has maximum the multiple bonds, so it will be taken as a parent carbon chain. Now what is the rule 2? If two chains have same number of multiple bonds, then check the maximum number of carbon, then the maximum number of carbon atoms is considered as parent carbon chain. For example, suppose if C double bond C, single bond C dash C, C double bond C. Suppose this also has C double bond C. Okay, then if this chain 1, 2, 3, 4, 5, 6, this also has two multiple bonds, right? 1, 2 multiple bond. If I go from here and if I go 1, 2, 3 and 4 and 5, right? It also has multiple double bonds. But straight chain, if I go 1, 2, 3, 4, 5, 6, although 6 carbon atom, but it has only one double bond. Here in this, it has two double bonds. Here also it has two double bonds. Now, as the rule says, if they have same number of multiple bonds, then the maximum number of carbon chain is considered as the parent carbon chain. So I will consider this as the parent carbon chain, because this has the maximum. First condition, it has maximum multiple bonds, and then second condition, it has maximum number of carbon chain. Fine. We will see. Then rule the multiple bonds. If the multiple bonds and the carbon chain, and you can say and the carbon, both are same, then the maximum substituent is selected as the parent carbon chain. Fine. I will see one example. Take for instance, if the multiple bonds and the carbon chain, suppose 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. If here also I'll get two multiple bonds and 5 carbon atoms. If I go from here to here, then also it is 5 carbon atoms and 2 multiple bonds. Now from which side I should go? Then I should go then where there is maximum number of substituent. So if I go like that, fine. Here how many substituents are there? Only one substituent is there. But if I go straight, here one substituent here, one substituent here. That means two substituents are present. Then I can go from here 1, 2, 3, 4 and 5. Fine. Straight chain if I am going. Then it is two substituents are there. Two substituents and two multiple bonds. But I will not go here like that. I will go like that because it has two substituent. Fine. I can say what the preference, who is given the most preference. First, the number of multiple bonds. First, the multiple bonds is given the first preference. Then the number of carbon atoms. And then the number of substituent. Fine. Number of substituent. This is very important. Make a note of it. Number of multiple bonds is given the first preference, then number of carbon atom, and then the number of substituent. Fine. Now rule 4. Now we will see the numbering of parent chain, how it has been done. First case, first three cases we saw which parent chain has to be selected. Now numbering of the parent chain. Parent carbon chain. Now, while doing the numbering, while numbering in an alkene and an alkyne, then the multiple bonds are given the lowest Locant number, or the lowest numerical value, lowest Locant number. Lowest Locant number has to be given to the multiple bonds. Take for instance, suppose this. Take for instance, I have to give the numbering. Suppose 1, 2, 3, or I can say 1, 2, 3. But the numbering has always to be given from the multiple bonds then. So that because they should get the lowest Locant number, lowest numerical value. That is, this is 1. Here it is 1. First carbon has a double bond. Where from here if I go then if 1, 2. Then the second carbon has. So this is the correct one. And this is the wrong. Fine. Now we have to see. Now what happens? Many a times a multiple bond. If a multiple bond gets the same number from either the side, from here also it is it has a numbering value the same either from the left and then the right, both side it has the same number, then it should get the minimum number to the substituent. Suppose now, fine, for example, suppose if the multiple bond gets the same number from the either side, from both the sides, then the substituent is given the preference or the lowest value. For example, C, single bond C, double bond C, C. Fine. And suppose here there is Br. Now if I go from here, it is 1, 2. At second carbon atom there is a double bond, and if I go from here 1, 2, here also second carbon atom, but a substituent is present at the second carbon atom. From here if I go, then the preference will be given to from this side. Why? Because a substituent is present. Then the substituent will be given the first preference for numbering. So the numbering will start from 1, 2, fine, 1, 2, 3 and 4. 1, 2, 3 and 4. If the double bond, if the multiple bonds, multiple bond means either double bond or triple bond, they get the same number from the either side, right? Then it will be 1, it will be then 2 bromo butene, 2 bromobutene. As we know, even from this we can say that multiple bonds, no doubt, is given more priority as compared to substituent, as we have seen in the previous slide. Fine. Okay. Yeah. Few examples. Couple of examples we will see. Suppose C double bond C dash C dash CH3 dash C. First, the secondary prefix. Secondary prefix will be given the first preference. Secondary prefix, then the secondary prefix, then the root name, and then the primary suffix. Right? Primary suffix. Now, it will be 1, 2, 3, 4. It will be 4 methyl pent, pent, 4 methyl pent, 1 ene. As I told you in the previous lecture that when a numerical number is separated by alphabetical, then it is separated by an hyphen, right? Pent, that A and E is removed and then it is substituted by the concerned prefix or suffix, right? Concerned suffix. So 4 methyl pent 1 ene, pent 1 ene. Fine. Now suppose if I take another example, CH3 CH double bond CH dash Br. Understood? It has to be given from here. Fine. Then it will be 1 bromo, 1 bromo prop 1 ene. 1 bromo because bromine is present, so the secondary suffix of bromine Br is bromo 1 ene. Fine. Now if I take some other example, now suppose the same example, now the Br happens to be here. Suppose now CH double bond CH2. As I have told you earlier, that the first preference has to be given for the multiple bond. 1, 2, 3. Here, because the double bond and the substituent both are there at one particular carbon atom, obviously then the preference has to be given here. But in this case, the substituent is at the third carbon atom, but the multiple bond is in the first carbon atom. So the preference has to be given here. Fine. Then it will be 3 bromo prop 1 ene. Prop 1 ene. Fine. Okay. Now we will go further now. Now, if I go from here, then it is 1 and 2. Second carbon atom happens to be a multiple bond. If I go from here 1 and 2, then second carbon atom has to be a same multiple bond. So equal, it is at a equidistant from on the either side, but it has to be mentioned from here. Fine. It has to be named from here. So it will be 1 bromo but 2 ene. Now we'll go for the next rule now. As we had seen that rule 4, now we'll go for rule 5. Now, so if what happens if two or more similar multiple bonds, are present on a parent carbon chain, if more than two if two or more than two multiple bonds are present on the parent carbon chain, then you will have to use as di, tri, tetra, right? For example, we will see this. One. So we will be naming 1, 2, 3, 4, 5, 6, and then 7. Fine. Then it will be hept 1, 3, diene. Hept 1, 3, diene. Hept means because the root name is heptane, so hept 1, 3, first position, and the third position is diene, because as I have told you, if this same multiple bond is situated on the parent carbon atom, then it is represented by either di or tri. Fine. We'll take one more. Who's fine. It will be 1, 2, 3, 4, 5, and it will be pent 1, 4, diene. Right? No. If alkene and alkyne both are present on the same parent carbon chain, if double bond and triple bond both are present on the same carbon chain, then the numbering is done. Both present on same carbon chain, then numbering is from alkene. Why alkene? Since ENE is alphabetically, ENE is E, and this is INE. This is why. So alphabetically E comes first and Y comes next. Therefore, E is given the first preference. For example, suppose one double bond. Fine. Now, here double bond is there, triple bond is there. Then obviously I will do the numbering from here. Why? Because it's in and A. So by alphabetically I have to give it the name. So it will be pent 1 in 3 ine. Pent 1 in 3 ine. Pent 1 in 3 ine. Fine. Now, fine. So it will be given 2 cyclopropyl, 2 cyclopropyl, eth 1 in, eth 1 in, 2 cyclopropyl, eth 1 in. Fine. Suppose now again I take one more again. I will take a last example. Suppose this is no, the numbering I have to do it. Then obviously I have to do the numbering. See 1, 2, 3, 4, 5, 6, 7. This one not only is the longest carbon chain but also the double bond forms here. If I take 1, 2, 3, 4, 5, 6. This is just 6 carbon chain. Here this is a 7 carbon chain. It's understood that it will be 1, 2, 3, 4, 5, 6 and then 7. Fine. Okay. Now we will see nomenclature of cyclic alkene. Fine. Nomenclature of cyclic. Actually, in cyclic alkene, all the rules and regulations remain the same as is there in a straight chain alkane and alkene. There is no change in a rule. We'll just directly see the examples. Now here there is the double bond starts from this carbon atom, right? But now this is 1. I can go 1, 2, 3, 4, 5, right? But if I go from here 1, 2, 3, this is the substituent. This is the substituent. Then as I have told you previously that first the multiple bond, then the number of carbon atom and then the substituent. But number of carbon atom, if I go from here also it is 6. Right? Here also if I am getting it 6. So then the preference will come with respect to substituent. Here the substituent is at the third carbon atom and here as at the fifth carbon atom. So 1, 2, 3. Fine. So it will be, you can say 3-methyl cyclohexane. Right? Now we shall do some more couple of examples just. Right. Now the numbering from here, if I do it, this it will be 1, 2, 3, 4. Or if I do from here 1, 2, 3, 4. Why I'll go 1 and 2? Because here there is a substituent. Why I'll go 1 and 2? Because here there is a substituent. But from where exactly I have to start? I'll get confused. Then I'll have to see the alphabetically. Who comes first? This is bromo and this is chloro. This is chloro and this is bromo. So here it comes 1, then it comes 2. Then it will be 1 bromo, 2 chloro, cyclobute, 1 ene, cyclobute, 1 ene. Right? Now, last example we will. Right? Now whether you have to number it from here or from here. Right? If the double bond, if I see it starting from here, then it will go 1, 2, 3, 4, 5 and then 6. If I check it out, if it is starting from here, then 1, 2, 3, again 4, 5 and 6. But I will go from here 1, 2, 3 because there are 2 substituents. So this has to be given the first preference. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Then it will be 6 bromo, 6 bromo, 3 ethyl, fine, 3 ethyl, 3 methyl, 3 ethyl, 3 methyl, cyclohex 1-ene, cyclohex 1-ene, cyclohex 1-ene, fine. 1, 2, 3, 4, 5, 6. Since this is the complex more, but two, it has two branches, then this has to be given the first preference. So it will be 1, 2. I can't go from here 1 and 2 because the double bond is starting from here. I have to take the complete double bond. So it will start from 1, 2, 3, not 1 and 2. Okay? Then 1, 2, 3. So it is 6 bromo, 3 ethyl. Okay? Fine. Now we will see nature of complex locant. What do you mean by complex locant? Complex locant means a substituent which is attached to a parent carbon chain. A substituent which is attached to a parent carbon chain but is very in complex. It is a complex substituent. Take for example like that. It is not a simple methyl, right? This is a complex substituent. This is a complex substituent, or you can say complex locant number. Fine. Now we will see some examples of complex substituents. Now the first will be this is known as 1-methyl ethyl, which is also known as isopropyl. Isopropyl. The second carbon atom has one C, 1-methyl. This is known as isopropyl. Now, fine. Now this is known as 2-methyl propyl. 2-methyl propyl. This is known as secondary butyl. Secondary butyl. Secondary butyl on the secondary butyl. Fine. It is extremely sorry. It is not 2-methyl. It is 1-methyl. I'm extremely sorry. It is 1-methyl. 1-methyl propyl. Right? 1-methyl propyl. That means it's known as secondary butyl. It was 1-methyl ethyl. 1-methyl butyl. So it is secondary butyl. Now, similarly, if I say fine. Now this is 2-methyl propyl. This was 1-methyl propyl and this is 2-methyl propyl. This is 1-methyl propyl which is secondary butyl. This is 2-methyl propyl which is known as isobutyl. isobutyl. Fine. Similarly, 1, 2, 3. Now, this is 2-methyl butyl, which is known as isopentyl. Which is known as isopentyl. Now, fine. Now, this is 1,1-dimethyl. I will say 1,1-dimethyl propyl. 1,1-dimethyl 1-dimethyl, dimethyl ethyl, which is also known as tertiary butyl, also known as tertiary butyl. Fine. Now, this is 1, 2, 3. This is 2,2-dimethyl propyl. 2,2-dimethyl propyl is known as neopentyl. Just make a note of it. This is 1-methyl ethyl isopropyl. This is 1-methyl propyl, which is known as secondary butyl. This is 2-methyl propyl, which is known as isobutyl. This is 2-methyl butyl, is known as isopentyl. This is 1,1-dimethyl ethyl, which is known as tertiary butyl. And this happens to be 2,2-dimethyl propyl, which happens to be neopentyl. Fine, this is very important. This will be frequently used, right? This is very, very important. Now, make a small note now that the complex locant will always be mentioned in a square bracket. Square bracket in the sense like that. Square bracket. Okay? Then second thing, if the complex locant is more than 2 or more than 2, then it is represented by as usual by di, tri and tetra. But in the previous case, what happened, there was that di, tri and tetra were not considered with respect to alphabetical value like D, T. No, it was not an alphabet. But here in the case of a complex locant, the more than 2 complex locant, 2 or more than 2 complex locant, they are denoted by di, tri and tetra. And the D, T will be given preference with respect to their alphabetical order in case of complex locant only. Right? In case of complex locant, when I have to denote the complex locant, then I will have to, suppose if 2 complex locant I get, di and tri, then I'll have to give first preference to di and then to tri, because in di, D comes first in alphabetically and T comes next. So here in this case, only and only I have to take the alphabetical order. Fine? Yeah. Now, if two or more similar complexes, similar complex locant, complex locant is present, then it is denoted by bis tris tetrakis. Bis means 2, tris means 3, and tetrakis means 4. Bis tris tetrakis. Fine? Tetrakis. Now, we will take a few examples. Fine? The naming 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. From anywhere you can give a name. 1, 2, 3, 4, 5. Fine? 1, 2, 3, 4, 5, 6, 7, 8. Fine? Then it will be 5. This will be written in a square bracket. This will be what? 5. This will be 1 and this will be 2. Right? 1. It is written in square bracket. Don't get confused that this is also 1, this is also 1. Here this one is due of the complex locant. This is for the complex locant which will be mentioned separately in a square bracket. Then 5, 1, 1 dimethyl. 1, 1 dimethyl, 2 carbon atoms, 1, 1 dimethyl ethyl, 1, 1 dimethyl ethyl, then bracket closed, nonane. Nonane means 9 carbon. Nonane. Fine. 5, 1, 1 dimethyl ethyl, because inside the square bracket it will be always YL, because some of the other alkyl groups are only going to get present here. So it will be always, don't by mistake, don't write dimethyl ethane. It is not dimethyl ethane, it is a complex, therefore it will be ethyl. Dimethyl ethyl nonane. Fine? Now, we will take a different example now. Take for example, we'll take this. Fine. Then here it will be sorry, here there is the complex 1. Sorry, cancel this. Take another example. Fine. One, sorry. Okay, now we'll see the another example. Fine. Then numbering will be 1, 2. So I will say it will be 1 methyl suppose this is 1, right? So 1 dash, this is a complex locant, 1 methyl, 1 methyl ethyl, 1 methyl ethyl, bracket closed. This is 1, this is the complex locant, 1 methyl ethyl cyclohexane, cyclohexane, 1 methyl ethyl cyclohexane. Fine. We will see a one more example. Fine. Now this will be 1, this will be 1, this is a complex. It will be 1 methyl cyclopropyl, 1 methyl cyclopropyl, bracket closed, cyclohexane, 1 methyl cyclopropyl cyclohexane. Fine. Now we will see some substituents which they themselves contain a multiple bonds. They themselves contain multiple bonds. Substituents containing multiple bonds. Fine. Now take for example CH double bond CH2, CH double bond CH2. So this will be known as, you can say this is known as ethinyl. Ethinyl. It is also known as ethinyl. This is a complex locant which contains a double bond. Ethinyl. Then CH2 dash CH double bond CH2. Then it is known as prop to enyl, ENYL, right? Prop to enyl. Fine. Similarly will be cyclobutyl. So it will be cyclobut 1 ENYL, cyclobutyl. Fine. Now one more last example we will see. Right? This will be 1, 2, 3, 4, 5 and 6. Suppose 1, 2, 3, 4 here. If I get double bond, I get a double bond. So 1, 2, 3, 4. 1, 2, 3 and then 4, 5 and then 6. Fine? No. So I will, in this case I will write 4-ethynyl 4-ethynyl hex 1, 2, 3, 4, 5, 6, 7 hept 4-ethynyl hept 1, 6 diene. 4-ethynyl 1, 6 diene. Four ethynyl hept 1, 6 diene. Fine? Yeah. If the substituent has a triple bond, no. Similarly, if I say C triple bond CH, then it will be known as ethynyl. YNYL, ethynyl, NYL, ethynyl, ethynyl, right? Then again similarly it will be propynyl, propyne 1-yle, this will be 1, propynyl. Similarly, if I take another more complex, one, two, three, four, in slow, suppose this 5, 6, 7. Here one double bond, here one double bond. Fine. So if I get 1, 2, 3, and then 4. In fourth position, 5, 6, and 7. So I will say 4-ethynyl THYNYL, 4-ethynyl hept 1, 6 diene. Fine? 1, 6 diene. Similarly, we'll have some another more complex CH double bond CH double bond CH2, you can see. This is also known as vinylic carbon atom. Then CH2 double bond CH2 dash CH dash CH2. This is known as allylic carbon atom. This is vinylic because the double bond is placed between two neighboring carbon atoms. This is allylic because the double bond is followed by another single bond. Double bond is followed by another single bond, right? Then this is allylic carbon atoms. Now what do you mean by, suppose if this is A and this is B, this is also A and this is also another also is A, right? Then this is known as geminal carbon atom. Carbon atom, because on the carbon atom it contains same functional group, geminal carbon atom. For example, you can say, suppose CH, here it is Cl, then geminal dihalide, you can say geminal dihalide, fine. And if CH, here there is A, CH, here there is A, and then this will be vicinal. Similarly, if here halides are present, then it will be known as vicinal dihalide. Geminal dihalide on the same carbon atom, same functional group is there, and on this is two different carbon atoms, same functional group is present. So it is known as vicinal, and this is known as geminal. Fine. Now the last part we will do at this point, nomenclature of epoxy. The secondary prefix itself is epoxy. Epoxy means like a cyclopropyl ring is there, one carbon atom is replaced by oxygen, therefore it is known as epoxy. So I will say, suppose 1 2, so it will be 1 2 epoxy ethane, because two carbon atoms of a parent chain happens to be ethane. So 1 2 epoxy, this is a epoxy group, so 1 2 epoxy ethane. Fine. Suppose and 1 3. This is the longest carbon chain. Fine. Then it will be 2-epoxy propane. 1,2-epoxy propane. Let's take the final example. Numbering will be 1, 2, 3, 4, 5 and 6. So it will be 2, 3, 2, 3, 4, 5. Suppose if I write like that, 2, 3, 4, 5 di-epoxy hexane. 2, 3, 4, 5 di-epoxy hexane. Okay. So friends, today we have done a basic complex locant. So now in the next lecture we will go with respect to nomenclature with respect to individual functional groups. When individual complex functional groups are present, then how will we give the naming? One part we have done alkanes, then alkenes, then alkynes, and now the complex locant we have done. So in the next lecture we will do the individual functional groups now. Okay? I hope you have understood. So please, if you have any query, you can just write me on my Twitter account or on my email ID, which I have mentioned in the comment in my description, and then you can ask any question if you want. So friends, I will take a leave and I shall meet you in my next lecture, in which I'll be doing the further nomenclature of different individual functional groups, right? So I shall take a leave. Bye. Goodbye. Namaskar. Thank you.